JEP 430, String Templates, Preview. Summary: enhance the Java programming language with string templates. String templates complement Java's existing string literals and text blocks by coupling literal text with embedded expressions and template processors to produce specialized results. This is a preview language feature and API. Goals: 1. Simplify the writing of Java programs by making it easy to express strings that include values computed at runtime. 2. Enhance the readability of expressions that mix text and expressions, whether the text fits on a single source line, as with string literals, or spans several source lines, as with text blocks. 3. Improve the security of Java programs that compose strings from user-provided values and pass them to other systems, for example, building queries for databases, by supporting validation and transformation of both the template and the values of its embedded expressions. 4. Retain flexibility by allowing Java libraries to define the formatting syntax used in string templates. 5. Simplify the use of APIs that accept strings written in non-Java languages, for example, SQL, XML, and JSON. 6. Enable the creation of non-string values computed from literal text and embedded expressions without having to transit through an intermediate string representation. Non-goals. 1. It is not a goal to introduce syntactic sugar for Java's string concatenation operator, plus, since that would circumvent the goal of validation. 2. It is not a goal to deprecate or remove the string builder and string buffer classes, which have traditionally been used for complex or programmatic string composition. Motivation. Developers routinely compose strings from a combination of literal text and expressions. Java provides several mechanisms for string composition, though unfortunately all have drawbacks. 1. String concatenation with the plus operator produces hard-to-read code. String s equals x plus 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 y plus equals plus x plus y, 2. String builder is verbose. String s equals new string builder append x append plus, append y append equals, append x plus y, to string. 3. String colon format and string colon formatted separate the format string from the parameters, inviting arity and type mismatches.
String s equals string dot format $2d plus $1d equals $3d, x, y, x plus y. String t equals $2d plus $1d equals $3d. Formatted x, y, x plus y.
4. Java.text.message format requires too much ceremony and uses an unfamiliar syntax in the format string.
Message format mf equals new message format, 0, plus, 1, equals, 2, string s equals mf dot format x, y, x plus y.
String interpolation. Many programming languages offer string interpolation as an alternative to string concatenation. Typically, this takes the form of a string literal that contains embedded expressions as well as literal text. Embedding expressions in situ means that readers can easily discern the intended result. At runtime, the embedded expressions are replaced with their stringified values. The values are said to be interpolated into the string. Here are some examples of interpolation in other languages.
$x plus y equals x plus y. Visual Basic $x plus y equals x plus y. Python f x plus y equals x plus y. Scala s $x plus $y equals $x plus y. Groovy $x plus $y equals $x plus y. Kotlin $x plus $y equals $x plus y. JavaScript $x plus $y equals $x plus y. Ruby #x plus #y equals #x plus y. Swift x plus y equals x plus y.
Some of these languages enable interpolation for all string literals while others require interpolation to be enabled when desired, for example by prefixing the literal's opening delimiter with $ or $f. The syntax of embedded expressions also varies but often involves characters such as $or, which means that those characters cannot appear literally unless they are escaped. Not only is interpolation more convenient than concatenation when writing code, it also offers greater clarity when reading code. The clarity is especially striking with larger strings. For example, in JavaScript, const title equals my web page, const text equals hello, world. var HTML equals HTML head title $title head body p $text p body HTML . String interpolation is dangerous. Unfortunately, the convenience of interpolation has a downside. It is easy to construct strings that will be interpreted by other systems but which are dangerously incorrect in those systems. Strings that hold SQL statements, HTML/XML documents, JSON snippets, shell scripts, and natural language text all need to be validated and sanitized according to domain-specific rules. Since the Java programming language cannot possibly enforce all such rules, it is up to developers using interpolation to validate and sanitize. Typically, this means remembering to wrap embedded expressions in calls to escape or validate methods, and relying on IDEs or static analysis tools to help to validate the literal text. Interpolation is especially dangerous for SQL statements because it can lead to injection attacks. For example, consider this hypothetical Java code with the embedded expression $name. String query equals select from person P where P.last_name equals $name result set rs equals connection.create statement. Execute query. If name had the troublesome value, Smith or P.last_name Smith, then the query string would be select from person P where P.last_name equals Smith or P.last_name Smith. And the code would select all rows, potentially exposing confidential information. Composing a query string with simple-minded interpolation is just as unsafe as composing it with traditional concatenation. String query equals select from person P where P.last_name equals plus name plus semicolon. Can we do better? For Java, we would like to have a string composition feature that achieves the clarity of interpolation, that achieves a safer result out of the box, perhaps trading off a small amount of convenience to gain a large amount of safety. For example, when composing SQL statements, any quotes in the values of embedded expressions must be escaped, and the string overall must have balanced quotes. Given the troublesome value of name shown above, the query that should be composed is a safe one. Select from person P where P.last_name equals \Smith or P.last_name \Smith. Almost every use of string interpolation involves structuring the string to fit some kind of template. A SQL statement usually follows the template select, from, where, an HTML document follows HTML/HTML, and even a message in a natural language follows a template that intersperses dynamic values, for example, a username, amongst literal text. Each kind of template has rules for validation and transformation, such as escape all quotes for SQL statements, allow only legal character entities for HTML documents, and localize to the language configured in the OS for natural language messages. Ideally, a string's template could be expressed directly in the code, as if annotating the string, and the Java runtime would apply template-specific rules to the string automatically. The result would be SQL statements with escaped quotes, HTML documents with no illegal entities, and boilerplate-free message localization. Composing a string from a template would relieve developers of having to laboriously escape each embedded expression, call validate on the whole string, or use java.util.resource bundle to look up a localized string. For another example, we might construct a string denoting a JSON document and then feed it to a JSON parser in order to obtain a strongly typed JSON object. String name equals Jones Smith, string phone equals 555 123 4567, string address equals 1 Maple Drive, Anytown, string JSON equals name, %s, phone, %s, address, %s. Formatted name, phone, address. JSON object doc equals JSON.parseJSON, doc.entry set. Stream. Map. Ideally, the JSON structure of the string could be expressed directly in the code, and the Java runtime would transform the string into a JSON object automatically. The manual detour through the parser would not be necessary. In summary, we could improve the readability and reliability of almost every Java program if we had a first-class, template-based mechanism for composing strings. Such a feature would offer the benefits of interpolation, as seen in other programming languages, but would be less prone to introducing security vulnerabilities. It would also reduce the ceremony of working with libraries that take complex input as strings. Description: template expressions are a new kind of expression in the Java programming language. Template expressions can perform string interpolation, but are also programmable in a way that helps developers compose strings safely and efficiently. In addition, template expressions are not limited to composing strings, they can turn structured text into any kind of object, according to domain-specific rules. Syntactically, a template expression resembles a string literal with a prefix. There is a template expression on the second line of this code. String name equals Joan, string info equals str. My name is name, assert info dot equals my name is Joan, / true. The template expression str. My name is name consists of 1. A template processor, str, 2. A dot character, U+002E, as seen in other kinds of expressions, and 3. A template, my name is name, which contains an embedded expression, \name. When a template expression is evaluated at runtime, its template processor combines the literal text in the template with the values of the embedded expressions in order to produce a result. The result of the template processor, and thus the result of evaluating the template expression, is often a string, though not always. The str template processor. str is a template processor defined in the Java platform. It performs string interpolation by replacing each embedded expression in the template with the stringified value of that expression. The result of evaluating a template expression which uses str is a string, for example, my name is Joan. In everyday conversation, developers are likely to use the term template when referring either to the whole of a template expression, which includes the template processor, or to just the template part of a template expression, which is the argument to the template processor. This informal usage is reasonable as long as care is taken not to conflate these concepts. str is a public static final field that is automatically imported into every Java source file. Here are more examples of template expressions that use the str template processor. The symbol in the left margin means that the line shows the value of the previous statement, similar to shell. / embedded expressions can be strings. String first name equals Bill, string last name equals Duck, string full name equals str. First name, last name, Bill Duck string sort name equals str. Last name, first name, Duck, Bill. / embedded expressions can perform arithmetic. Int x equals 10, y equals 20, string s equals str. X plus y equals x plus y, 10 plus 20 equals 30. / embedded expressions can invoke methods and access fields. String s equals str. You have a get off a type waiting for you. You have a gift waiting for you. String t equals str. Access at rec.date, rec.time, from rec.ip address. Access at the 25th of March 2022 1534 from 8.8.8.8. To aid refactoring, double quote characters can be used inside embedded expressions without escaping them as \. This means that an embedded expression can appear in a template expression exactly as it would appear outside the template expression, easing the switch from concatenation, plus, to template expressions. For example, string file path equals tmp.dat, file equals new file path, string old equals the file plus file path plus, file.exists. Does not, plus exist, string message equals str. The file path, file.exists. Does not, exist. The file tmp.dat does exist or the file tmp.dat does not exist. To aid readability, An embedded expression can be spread over multiple lines in the source file without introducing new lines into the result. The value of the embedded expression is interpolated into the result at the position of the embedded expression. The template is then considered to continue on the same line as the backslash. For example, string time equals str. The time is / the java.time.format package is very useful. Date time formatter. Of pattern HHMSS, format local time.now, right now. The time is 12:34 and 56 seconds right now. There is no limit to the number of embedded expressions in a string template expression. The embedded expressions are evaluated from left to right, just like the arguments in a method invocation expression. For example, / embedded expressions can be postfix increment expressions. Int index equals 0, string data equals str. Index plus plus, index plus plus, index plus plus, index plus plus, 0, 1, 2, 3. Any Java expression can be used as an embedded expression, even a template expression. For example, / embedded expression is a nested template expression. String fruit equals apples, oranges, peaches, string s equals str. Fruit 0, str. Fruit 1, fruit 2, apples, oranges, peaches. Here the template expression str. Fruit 1, fruit 2, is embedded in the template of another template expression. This code is difficult to read due to the abundance of backslash and characters, so it is better to format it as string s equals str. Fruit 0, str. Fruit 1, fruit 2. Alternatively, since the embedded expression has no side effects, it could be refactored into a separate template expression. String tmp equals str. Fruit 1, fruit 2, string s equals str. Fruit 0, tmp. Multi-line template expressions. The template of a template expression can span multiple lines of source code, using a syntax similar to that of text blocks. We saw an embedded expression spanning multiple lines above, but the template which contained the embedded expression was logically one line. Here are examples of template expressions denoting HTML text, JSON text, and a zone table, all spread over multiple lines. String title equals my web page, string text equals hello, world, string HTML equals str. HTML head title, title/head body p, text/p/body/html. HTML head, title my web page /title/head, body, p greater than hello, world/p/body/html. String name equals Jones Smith, string phone equals 555 123 4567, string address equals 1 Maple Drive, Anytown, string JSON equals str. Name, phone, address. Name, Jones Smith, phone, 555 123 4567, address, 1 Maple Drive, Anytown. Record rectangle string name, double width, double height, double area, return width height. Rectangle, zone equals new rectangle alpha, 17.8, 31.4, new rectangle Bravo, 9.6, 12.4, new rectangle Charlie, 7.1, 11.23. String table equals str. Description width height area. Zone 0. Name, zone 0. Width, zone 0. Height, zone 0. Area, zone 1. Name, zone 1. Width, zone 1. Height, zone 1. Area, zone 2. Name, zone 2. Width, zone 2. Height, zone 2. Area, total, zone 0. Area plus zone 1. Area plus zone 2. Area. Description width height area. Alpha 17.831.4558.92. Bravo 9.612.4 Charlie 7.111.2379.733. Total 757.693. The FMT template processor. FMT is another template processor defined in the Java platform. FMT is like str in that it performs interpolation, but it also interprets format specifiers which appear to the left of embedded expressions. The format specifiers are the same as those defined in java.util.formatter. Here is the zone table example, tidied up by format specifiers in the template. Record rectangle string name, double width, double height, double area, return width height. Rectangle, zone equals new rectangle alpha, 17.8, 31.4, new rectangle bravo, 9.6, 12.4, new rectangle Charlie, 7.1, 11.23. String table equals FMT. Description width height area, %12s /zone 0. Name, %7.2f /zone 0. Width, %7.2f /zone 0. Height, %7.2f /zone 0. Area, %12s /zone 1. Name, %7.2f /zone 1. Width, %7.2f /zone 1. Height, %7.2f /zone 1. Area, %12s /zone 2. Name, %7.2f /zone 2. Width, %7.2f /zone 2. Height, %7.2f /zone 2. Area, /. Repeat 28, total %7.2f /zone 0. Area plus zone 1. Area plus zone 2. Area. Description width height area. Alpha 17.830.140.558.92. Bravo 9.6012.40.119.04. Charlie 7.1011.2379.73. Total 757.69. Ensuring safety. The template expression str is a shortcut for invoking the process method of the str template processor. That is, the now familiar example. String name equals Joan, string info equals str. My name is, name, is equivalent to string name equals Joan, string template st equals raw. My name is, name, string info equals str.process st. Where raw is a standard template processor that produces an unprocessed string template object, the design of template expressions deliberately makes it impossible to go directly from a string literal or text block with embedded expressions to a string with the expression's values interpolated. This prevents dangerously incorrect strings from spreading through a program. The string literal is processed by a template processor, which has explicit responsibility for safely interpolating and validating a result, string or otherwise. Thus, if we forget to use a template processor such as str, raw, or FMT, then a compile time error is reported. String name equals Joan, string info equals my name is, name, error, processor missing from template expression. Syntax and semantics. The four kinds of template in a template expression are shown by its grammar, which starts at template, expression. Template, expression, template processor. Template argument, template processor, expression. Template argument, template. String literal. Text block. Template, string template. Text block template, string template, resembles a string literal but has one or more embedded expressions, and can be spread over multiple lines of source code. Text block template resembles a text block but has one or more embedded expressions. The Java compiler scans the term and determines whether to parse it as a string literal or a string template based on the presence of embedded expressions. The compiler similarly scans the term and determines whether to parse it as a text block or a text block template. We refer uniformly to the portion of these terms as the content of a string literal, string template, text block, or text block template. We strongly encourage IDEs to visually distinguish a string template from a string literal, and a text block template from a text block. Within the content of a string template or text block template, IDEs should visually distinguish an embedded expression from literal text. The Java programming language distinguishes string literals from string templates, and text blocks from text block templates, primarily because the type of a string template or text block template is not the familiar java.lang.string. The type of a string template or text block template is java.lang.string template, which is an interface, and string does not implement string template. When the template of a template expression is a string literal or a text block, therefore, the Java compiler automatically transforms the string denoted by the template into a string template with no embedded expressions. At runtime, a template expression is evaluated as follows. 1. The expression to the left of the dot is evaluated to obtain an instance of the nested interface string template.processor, that is, a template processor. 2. The expression to the right of the dot is evaluated to obtain an instance of string template. 3. The string template instance is passed to the process method of the string template.processor instance, which composes a result. The type of a template expression is the return type of the process method of the string template.processor instance. Template processors execute at runtime, not at compile time, so they cannot perform compile time processing on templates. Neither can they obtain the exact characters which appear in a template in source code, only the values of the embedded expressions are available, not the embedded expressions themselves. String literals inside template expressions. The ability to use a string literal or a text block as a template argument improves the flexibility of template expressions. Developers can write template expressions that initially have placeholder text in a string literal, such as string s equals str. Welcome to your account. Welcome to your account. And gradually embed expressions into the text to create a string template without changing any delimiters or inserting any special prefixes. String s equals str. Welcome, user.firstname, to your account, user.account number. Welcome, Lisa, to your account 12,345. User-defined template processors. Earlier we saw the template processors str and fmt, which make it look as if a template processor is an object accessed via a field. That is useful shorthand, but it is more accurate to say that a template processor is an object which is an instance of the functional interface string template.processor. In particular, the object's class implements the single abstract method of that interface, process, which takes a string template and returns an object. A static field such as str merely stores an instance of such a class. The actual class whose instance is stored in str has a process method that performs a stateless interpolation for which a singleton instance is suitable, hence the uppercase field name. Developers can easily create template processors for use in template expressions. However, before discussing how to create a template processor, we must discuss the class string template. An instance of string template represents the string template or text block template that appears as the template in a template expression. Consider this code. Int x equals 10, y equals 20, string template st equals raw. X plus y equals x plus y, string s equals st.toString. String template fragments equals, plus, equals, values equals, 10, 20, 30. The result is, perhaps, a surprise. Where is the interpolation of 10, 20, and 30 into the text plus and equals? Recall that one of the goals of template expressions is to provide secure string composition. Having string template colon to string simply concatenate 10, plus, 20, equals, and 30 into a string would circumvent that goal. Instead, the toString method renders the two useful parts of a string template. 1. The text fragments, plus, equals, and 2. The values, 10, 20, 30. The string template class exposes these parts directly. 1. String template :fragments returns a list of the text fragments coming before and after the embedded expressions in the string template or text block template. Int x equals 10, y equals 20, string template st equals raw. X plus y equals x plus y, list string fragments equals st.fragments, string result equals string.join \fragments, \+ equals \2. String template :values returns a list of the values produced by evaluating the embedded expressions in the order they appear in the source code.
In the current example, this is equivalent to list.of y, x plus y.
Int x equals 10, y equals 20, string template st equals raw. X plus y equals x plus y, list object values equals st.values, 10, 20, 30. The fragments of a string template are constant across all evaluations of a template expression, while values is computed fresh for each evaluation. For example, int y equals 20, 4, int x equals 0, x less than 3, x plus plus, string template st equals raw. X plus y equals x plus y, system.out.println st. Adding, and, yields, 0, 20, 20. Adding, and, yields, 1, 20, 21. Adding, and, yields, 2, 20, 22. Using fragments and values, we can easily create an interpolating template processor by passing a lambda expression to the static factory method string template.processor:of. var enter equals string template.processor.of string template st greater than string placeholder equals string stencil equals string.join placeholder st.fragments 4 object value st.values string v equals string.value of value stencil equals stencil.replace first placeholder v. Return stencil. Int x equals 10, y equals 20, string s equals inter. X plus y equals x plus y, 10 plus 20 equals 30. We can make this interpolating template processor more efficient by building up its result from fragments and values, taking advantage of the fact that every template represents an alternating sequence of fragments and values. var enter equals string template.processor.of string template st greater than string builder sb equals new string builder iterator string frag-iter equals st.fragments. Iterator 4 object value st.values sp.append frag-iter.next sp.append value sp.append frag-iter.next return sp.to string. Int x equals 10, y equals 20, string s equals inter. X plus y equals x plus y, 10 and 20 equals 30. The utility method string template :interpolate does the same thing, successively concatenating fragments and values. var enter equals string template.processor.of string template :interpolate. Given that the values of embedded expressions are usually unpredictable, it is generally not worthwhile for a template processor to intern the string that it produces. For example, str does not intern its result. However, it is straightforward to create an interning and interpolating template processor if needed. var intern equals string template.processor.of st greater than st.interpolate. Intern. The Template Processor API. All of the examples so far have created template processors using the factory method string template.processor:of. These example processors return instances of string and throw no exceptions, so template expressions which use them will always evaluate successfully. In contrast, a template processor that implements the string template.processor interface directly can be fully general. It can return objects of any type, not just string. It can also throw checked exceptions if processing fails, either because the template is invalid or for some other reason, such as an I/O error. If a processor throws checked exceptions, then developers who use it in template expressions must handle processing failures with try-catch statements, or else propagate the exceptions to callers. The declaration of the string template.processor interface is package java.lang, public interface string template, add functional interface.
Public interface processor less than R, E extends throwable, R process string template st, throws E.
The code shown earlier that interpolates strings. var inter equals string template.processor of string template colon interpolate, string s equals inter. X plus y equals x plus y is equivalent to string template.processor string, runtime exception inter equals string template.processor of string template colon interpolate, string s equals inter. X plus y equals x plus y. The return type of the template processor inter is specified by the first type argument, string. The exceptions thrown by the processor are specified by the second type argument, which in this case is runtime exception because this processor does not throw any checked exceptions. Here is a template processor that returns not strings but, rather, instances of JSON object. var JSON equals string template.processor.of, string template st, greater than new JSON object st.interpolate. String name equals Joan Smith, string phone equals 555 123 4567, string address equals 1 Maple Drive, any town, JSON object doc equals JSON. Name, phone, address. The declaration of JSON above is equivalent to string template.processor JSON object, runtime exception JSON equals string template.processor.of, string template st, greater than new JSON object st.interpolate. Compare the first type argument, JSON object, to the first type argument given to inter above, string. Users of this hypothetical JSON processor never see the string produced by st.interpolate. However, using st.interpolate in this way risks propagating injection vulnerabilities into the JSON result. We can be prudent and revise the code to check the template's values first and throw a checked exception, JSON exception, if a value is suspicious. String template.processor JSON object, JSON exception JSON underscore validate equals, string template st, greater than, string quote equals backslash, list object filtered equals new array list 4, object value, st.values, if, value instance of string str, if, str. Contains quote, throw new JSON exception injection vulnerability. Filtered.add quote plus str plus quote, else if, value instance of number vertical bar value instance of boolean. Filtered.add value, else, throw new JSON exception invalid value type. String JSON source equals string template.interpolate st.fr arguments, filtered, return new JSON object JSON. Source. String name equals Joan Smith, string phone equals 555 123 4567, string address equals 1 Maple Drive, any town, try, JSON object doc equals JSON underscore validate. Name, phone, address. Catch, JSON exception X. This version of the processor throws a checked exception, so we cannot create it using the factory method string template.processor:of. Instead, we use a lambda expression on the right-hand side directly. In turn, this means we cannot use var on the left-hand side because Java requires an explicit target type for the lambda expression. To make it more efficient, we could memorize this processor by compiling the template's fragments into a JSON object with placeholder values and caching the result. If the next invocation of the processor uses the same fragments, then it can inject the values of the embedded expressions into a fresh deep copy of the cached object. There would be no intermediate string anywhere. Safely composing and executing database queries. The template processor class below, Query Builder, first creates a SQL query string from a string template. It then creates a JDBC prepared statement from that query string and sets its parameters to the values of the embedded expressions. Record Query Builder connection con implements string template.processor prepared statement, exception. Public prepared statement process string template st throws exception //1. Replace string template placeholders with prepared statement placeholders. String query equals string.join st.fr arguments //2. Create the prepared statement on the connection. Prepared statement ps equals con.prepare statement query //3. Set parameters of the prepared statement. Int index equals 1, 4, object value, st.values, switch, value, case integer I, greater than ps.set int index plus, I, case float f, greater than ps.set float index plus, f, case double d, greater than ps.set double index plus, d, case boolean b, greater than ps.set boolean index plus, b, default, greater than ps.set string index plus, string.value of value. Return ps. If we instantiate this hypothetical query builder for a specific connection, var db equals new query builder con. Then instead of the unsafe, injection attack prone code, string query equals select from person p where p.last_name equals plus name plus semicolon result set rs equals con.create statement. Execute query. We can write the more secure and more readable code. Prepared statement ps equals db. Select from person p where p.last_name equals name, result set rs equals ps.execute query. It might seem convenient for the template processor itself to execute the query and return the result set, allowing the client to write result set rs equals db. Select, however, it is unwise for a template processor to trigger potentially long-running actions in order to compose a result. It is also unwise to embark upon actions that can have side effects, such as updating a database. The authors of template processors are strongly advised to focus on validating their input and on composing a result that gives maximum flexibility to the client. Simplifying localization. The FMT template processor, shown earlier, is an instance of the template processor class java.util.format processor. While FMT uses the default locale, it is straightforward to create a template processor for a different locale by instantiating the class differently. For example, this code creates a template processor for the Thai locale. Locale Thai locale equals locale.for language tag ththu new Thai, format processor Thai equals new format processor Thai locale. 4. Int I equals 1, I less than equals 1000, I equals 10. String s equals Thai. This answer is %5d\i, system.out.printlns. This answer is, this answer is, this answer is, this answer is, this answer is. Simplifying use of resource bundles. The template processor class below, localization processor, simplifies working with resource bundles. For a given locale, it maps a string to a corresponding property in a resource bundle. Record localization processor locale implements string template.processor string, runtime. Exception. Public string process string template st. Resource bundle resource equals resource bundle.get bundle resources, locale, string stencil equals string.join _ st.fr arguments. String msg format equals resource.get string stencil.replace comma dot, return message format msg format, st.values. 2. Array. Assuming there is a property file resource bundle for each locale. Hash resources _n_ca. Properties file. No.suitable._.found.for.__ equals \no suitable, 0. Found for 1 2. Hash resources _zh_cn. Properties file. No.suitable._.found.for.__ equals \u5bf9 \u4e8e12 \u627e \u4e0d \u5230 \u5408 \u9002 \u7684 0. #resources_jp.properties file. No.suitable._.found.for.__ equals /(1)/(u364)/u364/u364b/u300b/u364c/u898b/u30064b/u380b/u30004b/u30008a/u305b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/u300b/ var user locale equals locale.of_n, ca, var localize equals new localization processor user locale, var symbol kind equals field, name equals tax, type equals double, system.out.println localize. No suitable, symbol kind, found for, name, type. And the template processor will map the string to the corresponding property in the locale appropriate resource bundle. No suitable field found for tax double. If the program instead performed var user locale equals locale.of_zh, cn, then the output would be tax double, field. Finally, if the program instead performed var user locale equals locale.of_ja, then the output would be tax field, double. Alternatives. 1. When a string template appears without a template processor, then we could simply perform basic interpolation. However, this choice would violate the safety goal. It would be too tempting to construct SQL queries using interpolation, for example, and this would in the aggregate reduce the safety of Java programs. Always requiring a template processor ensures that the developer at least recognizes the possibility of domain-specific rules in a string template. 2. The syntax of template expressions, with the template processor appearing first, is not strictly necessary. It would be possible to denote the template processor as an argument to string template :process. For example, string s equals the answer is %5d\i. Process fmt. Having the template processor appear first is preferable because the result of evaluating the template expression is entirely dependent on the operation of the template processor. 3. For the syntax of embedded expressions we considered using $, but that would require a tag on string templates, either a prefix or a delimiter other than, to avoid conflicts with legacy code. We also considered \, and \, but, and, are likely to appear in embedded expressions, is less likely to appear, so visually determining the start and end of embedded expressions will be easier. 4. It would be possible to bake format specifiers into string templates, as done in C#. var date equals datetime.now, console.writeLine $the time is, date hhm. But this would require changes to the Java language specification any time a new format specifier is introduced. Risks and assumptions. The implementation of java.util.format processor depends strongly upon java.util.formatter, which may require a significant rewrite.